So I'll let you guys take your seats. This might be quick, this might be long. It depends on how, I guess, tired we all are. But basically, this is the format. So these are the first workshop leaders that went from 1 to 2. They're going to give a quick summary of what the workshop happened and all that. Oh, is that you're the second one? Second one. No, thanks. Thank you. And then after they speak, we'll open up for Q&A. And then we'll bring the next session on after that. Does that sound good? Awesome. Okay, who wants to go first?
Okay. Okay, my summary. So the session was really great because the only preparation I had done was like diving down a rabbit hole of protocol implementations to protocol changes to. Oh yes, my session was called, I forget what it was called, but it was about transitioning to more privacy or like increasing privacy adoption. So the only preparation I had done was to like just dive into potential protocol changes behind that. But then people started asking great questions. So, so some of the really important takeaways I thought came from some of those big picture questions. Like, so first of all, do we want to make privacy mandatory, or more specifically shielded transfers mandatory, or just a default? So that was a good question. Another one was, if we're going to do this kind of transition, then how should we decide when to do it, not just how to do it? For example, we don't want to shut off or preclude important use cases if the new shielded transfers don't support certain features, say multi-sig, then maybe it's too soon if people rely on that use case. So those are two big picture questions that were important. We went over a list of pros and cons. You know, a pro of having mandatory privacy is then you have fungibility. Also, one that I loved was if the whole system is just always private, then you don't need an excuse for why you were using privacy. If you know, so that's a huge one. Other advantages are potentially removing technical debt. The privacy mental model and the UX can be simpler, so users don't have to keep track of like which different operations they're doing or why they're different. They just do the same thing all the time, and then their expectations hopefully tend to be more correct. Cons, it might preclude use cases. Right now there's a notable performance difference, both in like transaction creation, verification, transaction throughput, and blockchain scalability. Also, we benefit a lot from having compatibility with Bitcoin tools and infrastructure. So the question is, how valuable is it to maintain that? So then we kind of got back around to where I started with, which was brainstorming different implementation details. So, so in the first case, we can educate people to use privacy. The second case, we can change the tools that they use to help them do the right thing, like by default. There's a few ways to break that down. One is by basically deprecating transparent addresses in various ways. So like one way is turn off the ability to receive, so you can still keep your key buried in your backyard for 10 years, but once you dig it up, you have to shield it. Then there's like this whole area of like incentivizing usage of privacy in the protocol, like having some sort of financial benefit if you're storing funds in shielded transactions, or some sort of penalty if you're using transparent transactions. And then there's a few fun ones like magically transitioning transparent addresses to have privacy. We don't know if it's necessarily how feasible that is, and also some people expressed concern that people who are using transparent transactions may have been doing so explicitly because they thought it had certain transparency properties, and so just suddenly changing that might violate their expectations. And then one way over on the edge here is we could just make a new system and then make a way to transfer Zcash from the existing system into the new system. Or the more extreme thing is just make a new system, just have two systems, have a new one that's cool. Yeah, so I think that's the summary. Who's next?
I guess I'm next. Cool. So yeah, the workshop that I was doing at the same time of that was on developer libraries, and sort of went through a couple of bits there. So we sort of started off looking over at the sort of the space of what is currently there, and sort of tying into what Nathan said about the fact that we're trying to leverage at the beginning the fact that we could be compatible with Bitcoin for adoption and things, which meant that we were taking these Bitcoin libraries and us in the community were modifying them to support Zcash. But that's not really a sustainable way to run the environment. And so we went through a couple of different topics around how, what sort of things that people want to be able to do with these libraries, and whether the current libraries are sufficient, whether the current setup of having, you go to this library if you want to do this kind of thing for this wallet or this currency, and then you have to go to a different library to do a different wallet, and sort of on that topic, the mental friction required to switch from one to the other, and how to balance that against the overhead of developing multi-currency, multi-token libraries, particularly in the context of the fact that within the Bitcoin model, you have Bitcoin and Bitcoin-derived currencies that are very similar, and then you have a couple of things like Zcash and I think Decred that shift it very differently. And then, of course, you have non-Bitcoin-derived currencies that are even more different. And then you have Ethereum, which is account-based, and how do you even deal with that in a wallet that uses a UTXO model? So, mapping all of these APIs together and figuring out some sort of not necessarily a one standard way, but a couple of different strategies to deal with the dimensional complexity and the dimensional explosions that can, combinatorial explosion that can go on. We also looked a little bit at the potential architecture of Zcash libraries, like Zcash specific libraries, for the purpose of sort of the bits of the crypto bits of Zcash that we don't want to have, the JavaScript and the Java and the Python, all the developers having to re-implement all of these bits and pieces all the time for the same core things. We kind of want to make sure that we can abstract that out into a core piece that we can, A, make it easier for people to adopt it, and B, make sure that things like privacy concerns and things can be appropriately handled by people who have the requisite contextual knowledge. We had a bit of a discussion on how that split might look like, and one action point that we're thinking of is we're going to set up a mailing list, probably through the foundation. We'll see about that, and to sort of start some discussions going on amongst participants here, and also to get some feedback from relevant community members, so people who are operating exchanges and wallets and things within the existing cryptocurrency ecosystem, but then also people like payment processors or browser developers or anyone else who might want to interact with us or more generally cybercoin payment systems as a whole, and try and start building a bit more consensus on the APIs and methods we want to actually use to do this.
It's going to die with my notes on it. My section was on interoperability, and I went over some of the things that Zcash has done to support interoperability in the past year, and then we had a discussion about what kind of vision of interoperability would people like to see in the blockchain ecosystem, and also what are the interoperability initiatives or projects that they find most promising, and what Zcash could do to support interoperability going forward. So first I gave a summary of what we've done to catch everyone up, and I'll give it a little bit of it here. Basically, we have tried to support interoperability through building tools to demo, encouraging the development of third-party interoperability tools, and working towards standards. And we've done some of this in the past year, but recently have focused all of our resources on, of course, the sapling and overwinter network upgrades. And in the future, maybe the Zcash Foundation will take on more of the work through grants and things like that. And so I went over the tools we built. One was a Zcash to Bitcoin atomic swap command line tool. And then once we demoed that, the foundation funded a JavaScript developer to work on a web client for that. And so that's currently still under development. And then we built, for a hackathon, we built a Zcash to Ethereum atomic swap tool. And recently, someone else has taken that up and decided to make it a bit more user-friendly and more usable. So those are the two things that we built in-house. And then in terms of development of third-party interoperability tools, we've tried to support where we can and have tried to support the development of standards that would increase interoperability. So then after the section where I gave the summary, we had a discussion and a brainstorm on Post-it notes and got a bunch of ideas. So among the answers to the first question, what kind of blockchain interoperability would you like to see? We got the answers, decentralized cross-chain swaps, formation of an interoperability working group, using Zcash as a mixer VPN, direct messaging between chains, interoperable smart contracts across currencies, snark verification on other blockchains, better UX, MetaMask for everything, mobile wallet decentralized swaps. And then for answers to the second question, what do you see as the most promising interoperability initiatives? We got several answers were Cosmos and Polkadot and Lightning Network, and then Decred, BlockNet, Block Collider, who we actually had someone there who was able to explain it for us because he was working on the project, Interledger, Zcash XCat, Agoric, Socrates, Ethereum smart contracts to verify ZK proofs, IPLD queries for blockchains, securing custody for blockchain trades. And then for the third question, interoperability going forward, we got the suggestions: scripting support for shielded transactions, participate in an interoperability foundation or cooperate to form one, finance integration of mobile apps, ZK proof standards, and formally define HTLC opcode format, standardized interop function communications, and support for secondary coins in shielded TXs, Dev Summit is Bolt compatible. All right, that was the results of our brainstorm.
Hi everyone. I ran the user experience workshop and we talked about some of the problems that Zcash is facing and what we could maybe do about them. We talked about features that we would like to see in applications that would be really good for the use case of spending Zcash as cryptocurrency instead of what's out there today. And we talked about some takeaways and clarifications that I want to bring up to the broader audience. Before that, I think I want to clarify that the Zcash company, we are trying to do in-house UX work ourselves. We are also trying to support our partners who have Zcash integrated into their applications and work with them for a more standardized user experience. And we are trying to write documentation and provide resources for the community so that they can also know what to do and also know what our preferences are on that. So we are doing everything in that area. I think the problem that is very apparent to everyone is that people aren't using shielded addresses, and there was a research paper talking about, well, even if you do use shielded addresses, that also sucks. But there are additional problems beyond that, and 3 of them are: 1, currently you need to choose between security or privacy because a lot of hardware wallets don't offer shielded address support. So by opting for that more secure option, you either have the option for a hardware wallet that supports T addresses or a software wallet that supports Z addresses. And that's kind of a terrible trade-off to make, and I don't know what the right one is. So maybe we can just fix that by offering some options, but that's easier said than done. We talked about how shielded transactions need to improve, but we also talked about how do we transition people from using transparent addresses to shielded addresses. That's a really difficult question, and we don't know what to do about the coin should we choose to transition. We also talked about how confusing our terminology is. We have 4 types of transactions. When other people have 1, we arguably have more because we have some sort of mixed transactions. That's pretty confusing. I think that if we were to build an app that's targeted for people and encouraging use of Zcash as a cryptocurrency, we thought that 3 ideas would really help. The first idea is to create some sort of address book tied to a keybase so that you don't need to ask everyone for their address and people can update their address if they want to. We would like the feature for reoccurring payments somehow or scheduled payments because everything is on a monthly subscription basis nowadays and it's really cumbersome to do it over and over. So just something that helps reduce the amount of work that users need to do currently. And we also want to start having a more feature-rich environment where people can have multiple Zcash wallets, because right now we only have Zcash in multi-currency wallets and you can only have 1, but we would like a Zcash wallet that supports Zcash features but also allow you to have multiple accounts like you could at a bank or something like that. So I think that that's what we talked about. Some takeaways, 3 quick ones. Onboarding is a pain point. We should do something about that. Secondly, we shouldn't solve everything with user interface or user experience because we could do it at the protocol level. We could help with user education and setting expectations as well. And something that I personally took away was that Zcash is hard to teach, but we shouldn't just all hold our breath and wait for sapling to happen and T-adders to be depreciated. We should actually do something about how messy it is now, because my personal take was, oh, I just want to build an app that only supports Z2 addresses, and then every user from then on is going to be in the right, and I don't know what to do with everyone being left behind. But that's a really bad way to think. And I don't think that people say that out loud, but I feel like a lot of us have thought that before, so let's not do that.
Hi, Dara and myself were at the mining workshop, hoping to facilitate a good discussion. There was wide representation of people, GPU enthusiasts, miners, hardware manufacturers, folks from other cryptocurrencies, and also the Zcash Foundation. There is a handout that was produced with some data points that would help to guide the conversation, and that will be made available later on today. Do you want to talk about the engineering roadmap and then?
Okay. So one of the things that I think is underappreciated is how long it takes to make protocol upgrades. Because on the discussion of proof of work changes on the forums and so on, a lot of people have been assuming that we could make a change, I don't know, within a month or something like that. It'll actually take about 6 months to prepare any protocol change, so that the lead-in time is very long. And that constrains what we can do. So we talked about that, and we talked about options for what we could do in the next upgrade after sapling, which is called, the code name is NU2. And some of the options were we could do nothing, just leave the proof of work as the status quo, allow ASICs to take over essentially. We could move to Equihash with different parameters. It wasn't clear that that would actually achieve ASIC resistance, and I think from some of the things I've learned and some of the things that the hardware manufacturers said, it's unlikely that that approach would be able to prevent ASICs in the long term. We could move to a different proof of work that would be more likely to resist ASICs in the longer term, ProgPower or something like that. We could, can you remember what the other options were? Yeah.
Yeah, so the way we eventually managed to get all our collective thoughts together is we actually put a chart together. And on the x-axis, think of our network upgrades, starting from where we are today with Overwinter NU0, we have Sapling NU1. Approximately 6 months after that, there'll be NU2 and NU3. So that's the x-horizontal axis. On the y-axis, think of the opportunity cost of how much effort it takes the engineering team to implement different features, for example, cross-chain atomic swaps, asset tokens, scalability, fixes, etc. And it came from discussion that tweaking the Equihash parameters, if we committed to that soon, certainly with the company and perhaps the foundation, then that would go into NU2, which would be around April of next year. And that would be a lower opportunity cost because the engineering team are familiar with Equihash, and we could get on with other things. If we wanted to move to something like ProgPower or something which is new to the team or some other scheme, there would be a higher opportunity cost, so some of the features that we want to get into NU2 might not make it. And Zuko also talks about another type of proof of work that he wants to get to eventually, sort of a multi-faction stakeholder proof of work, where the scheme will allow different mining factions and different types of hardware, assuming that they achieve their best possible rate, will get a relative equal share of the mining reward. And so for all of these, we think it might be possible. For that one, we think it might be possible for NU2, although I think we had a discussion where we thought the security analysis and that would take a lot longer. And so the way we've typically done upgrades has been, so far, sort of a tick-tock mechanism, where Sapling is a circuit change. So for the next upgrade after that, it doesn't change the circuit, but NU3 after that will change the circuit. So if we missed NU2, it would have to be NU4, unless we change our plan. One of the things that did come out was that the status quo will change eventually. Nobody wants it to be there forever. So it's just a question of timing and how we, also the foundation as well will have to say in this.
Yeah, we also talked to some extent about the limitations of proof of work security in the long term. So it isn't clear that proof of work is a sustainable mechanism of doing distributed consensus that will resist attacks in the long term. And we're seeing that with lots of attacks on other coins, especially coins with lower hash rate relative to Zcash or Bitcoin or whatever. So there was some discussion of moving to proof of stake, but lots of unsolved problems in there, and I think our position is still to wait and see what happens with Ethereum there.
And from discussion, there was sort of a agreement that if a change is to be made, whether it's just a tweak or something more advanced like ProgPower or multi-faction proof of work, we would have to commit pretty soon and do the and probably commit before Sapling. And Zuko has pointed out that if we're unable to make that to declare that by Sapling when it launches, then it will have to miss NU2. So ideally, we'd get everything, all stakeholders would come together and reach some kind of consensus before Sapling activates due to the roadmap.
Even before then, I think we need probably an 8 months lead up, something like that.
Okay, thank you.
Okay, so we'll go into Q&A. Feel free to raise your hand. We have 2 mic runners. When you ask your question, please announce your name and your affiliation if you'd like, and then who the question is directed to. And please make it a question. Anyway? No?
Hey, are the risks and right way to do a blended proof of work understood in that if you adopt multiple proofs of work, do you gain the benefit and additive benefit, or do you are you at the risk of the weakest?
I didn't hear the last part there.
Or, is it yet known how to blend multiple proofs of work so that having more than one option or perhaps having them in a proportion gives you the benefits of decentralization from both, or does it put you at the risk of either being gamed independently? Is that well understood? Does that need more research? Is that a likely path?
Simple answer, no. There's a lot of risk that if you go to a multi-algorithm proof of work, then you fall between two stools and don't get the full security benefits of any. And I'm personally very concerned about that. I'm a lot more skeptical than Zuko is about the security properties of multi-algorithm proof of work. On the other hand, it does have the advantage of sort of keeping a balance between different parts of the community, maybe. Did you have anything to say about that, Simon?
No,
Okay.
One note on that, though, is that there is a fair bit of data available because there are a bunch of other more closer to Bitcoin cybercoins that one of the things, pretty much the only thing they changed was to go to that kind of different proof of work, and otherwise we're very similar. I don't have to hand any of the hash power data on that, but if someone were to go and do like a longitudinal study of the various cryptocurrencies that have tried this kind of thing, I mean, all the data is there in the blockchain as far as how difficulties and things went and how upgrades and things went. It'd be great to see someone do that kind of data, collect and analyze that kind of data, which would make it much easier to inform these kinds of decisions for us.
Actually, sir, you had a question. Oh, awesome, thank you.
Hi, I had a question for Nathan about the deprecation of T addresses, which was something that was mentioned in Mary Mallory's presentation earlier. I don't know if she's still here, but she mentioned very quickly or like fleetingly at the end about how it might come with other sort of like more system-wide trade-offs, such as I think very briefly alluded to the setup phase becoming more of a concern. So I was wondering if you could expand on that, if you're aware of those challenges.
Yeah, there was something similar to that. So if I understand the question correctly, is if we like turn off T addresses some safe-ish way, then does that make the system more vulnerable if there is like a break in the existing shielded transfer system? Or another thing that came up that was kind of similar to that was what if there were regulation that says you can't do shielded transfers, but you can do transparent transfers? And so in one world with a Zcash that has transparent transfers, that Zcash could keep operating partially. Yeah, so I think those are risks. So it sounds like Dara has something to say, but my personal feeling is that the true resiliency for cryptocurrencies comes from the fact that there are multiple cryptocurrencies, at least right now. And so to me, it doesn't sound too compelling that if Zcash has these two different things, but something catastrophic happens to the shielded transfers, I I mean, I think that may provide some protection to whoever happens to be using transparent transfers at that point, but I think it would be devastating probably for the whole Zcash blockchain. So that's my personal feeling, but I gather that Dara has some personal feelings about it too.
Yeah, so we already incur the risk that if there's a balance violation bug in the shielded protocol, then anyone using T addresses is affected. There's really no way to separate those protocols if you allow shielding and de-shielding transfers. A balance violation is in the whole system, it's not just in the shielded addresses. So a caveat to that is when we switch to sapling, we're making a change to which proofs are used. So if there was a balance violation that we didn't detect previously, when we switch off those old kind of proofs, that kind of vulnerability can no longer be exploited. So if you were an attacker and you knew about the vulnerability while you could still exploit it, then you would obviously do that before the change. So it's not clear how much extra security that's actually giving you. But in the long term, as proof systems evolve and maybe some of the ones that were previously used get broken, you do want to be switching off old algorithms and no longer relying on them. For the same reason that you do in any cryptographic algorithm sort of evolution.
In the back.
Hey, so the original question was whether there was a trade-off between having transparent addresses and being able to audit shielded. Okay, sorry. Hi. Oh, whoops. Okay, so yeah, so the original trade-off was between whether or not you had shielded addresses, whether you could audit in case there was some kind of counterfeiting bug or something like that, and whether or not you had transparent addresses in the system. And I think that's not an actual trade-off that exists, because we can have no transparent addresses in our system, but still transparently allow people to move funds between shielded systems as we upgrade them. So there's not necessarily the case that we have to embrace transparent addresses. I just wanted to point that out.
Yeah, that's definitely the case. And yeah, to push back a little bit on Nathan's personal opinion, it's not necessarily the case that that a vulnerability in, say, in the Sprout value pool would necessarily tank the entire currency. At the moment, given that Sprout's the only pool that exists, that's, if that would have a problem, then that could be significant. But when we have sapling there, and potentially if we end up with in a future network upgrade 3 where we have another value pool, there is some distribution of risk across them, and because you get essentially independent auditability of the individual value pools. A bug in one does not mean that you can still, if there's a bug in one of them, you can still reasonably rely on a later independent pool, at least having a different set of possible bugs.
It basically depends when you find the vulnerability and whether there's a chance that people could already have exploited it before you can fix it. Which is, I guess, is the same for any security vulnerability.
Hey, it's more a comment than a question. There's an interesting maybe question for the community in this context. Say the first value pool is hacked somehow, and you see it by the fact that more value is coming out than came in. So the interesting question for the community is, what policy do you make? Do you make, one option is if X came in, you only allow X to come out. The disadvantage of that is that the hacker, probably some of that X is theirs, and some of the honest participants' funds will be stuck in the pool, frozen in the pool. So you could say, all right, if X came in, I'll allow X plus 20% to come out of the pool. So that's just an interesting, interesting question, I think.
I have a strong opinion about this. I think that if you detect something like that, you should shut down the whole blockchain immediately. No, immediately, and then figure out what to do.
Okay, well, thank you guys so much. We're going to go ahead and switch to the second group of workshop leaders.
Who should shut it down? No.
I'm sorry. But we'll go ahead and switch to the second group of workshop leaders. So thank you guys so much.
Now you can go.
And as a reminder, please tell us what your workshop was on. And who wants to go first?
Marshall and I led the developer infrastructure workshop, and I think a vast majority of the conversation centered around like documentation and sort of like guidance around just what exists now, and then also what we're developing in the future and how to best interact with the ecosystem. And so I think we spent a lot of time just discussing like things that we're working on to help the documentation, and also things that might help clients or exchanges or miners integrate Zcash into their ecosystems, and how we can either as the foundation or the company provide better guidance to other organizations that want to use the technology. So I think that, and just all the way from like just using transactions and testing to like, you know, Zcash as a service potentially. And Gio.
Just to expand on that a little bit, so we realized that there was a lot of knowledge in the community, and we kind of wanted to have a source of truth for that. So as part of the documentation process, we talked about how we're creating read the docs, and more or less what we wanted is just to understand how everyone was going to contribute to read the docs so that we can organize it in a fashion that when it scales, we don't have this just huge collection of documentations that doesn't make sense or flow. So we also wanted a way that instead of people just submitting stuff, they could go and use it like code. So we went over some of the nuances of read the docs and explaining how that's going to end up in its final form. But the big goal of that was just to kind of capture everyone's knowledge, but have a tool that anyone can contribute and anyone can kind of moderate. And that way, eventually, we'll have a smooth transition from like the Bitcoin kind of core knowledge to just referencing our docs explicitly. And that way, everyone just has like a source of truth, and everything for what everyone is working on is in one central location. So.
I facilitated the workshop on the what's called the encrypted memo field. So if you send a transaction to a shielded address, you can set an arbitrary data blob that's 512 bytes. And it's the case that this blob is being parsed out and used currently in at least one application I know of, which is something called zboard.net, which if you haven't poked around with it, you should. It's pretty cool. The demo there is that they take the data out and post it on a forum-like website so you can publish this data. So currently, there is no structure defined for this 512 bytes, and Arcalenia that proposes a standard for it, and so that was our starting point for the conversation. We discussed whether or not to add any structure to the array. We discussed naming conventions, whether encrypted memo field was in fact the best name. We discussed the possibility of having a registry of applications that would be described either in the memo field or in the receiving address, and how that registry might be defined and might look. I can summarize some of the, I think, sort of leanings of the group. I think we sort of lean towards the idea of renaming it the encrypted message field. We liked the idea of making what we started calling the app registry be some fixed width number of bits that would hold a fingerprint of a public key for your application, which then would consume the rest of the data. We sort of, I don't think we had a very solid suggestion for how that registry should be run, but I think there are a lot of obvious and good solutions for that. We discussed the idea of calling the remaining data the payload, and yeah, so I'd be happy to take questions later, and you should, if you're interested, check out Zip302 on GitHub.
Hi again. So the second workshop that I facilitated was on sort of wallet scalability, and in particular sort of the design of light clients. So about half the time I was sort of we went over what a shielded light client could look like. So obviously, in the transparent case, for transparent addresses, Zcash operates in a very similar way to, basically the same way to how Bitcoin-like clients and SPV-like nodes are currently run, either communicating directly with the peer-to-peer network, communicating with some aggregation service like an Electrum nodes or a Bitcore block explorer API, or some custom server that provides additional services. In the shielded case, obviously that creates a lot of privacy issues around the fact that you really don't, if you're dealing with a server or any server, you don't really want them to be knowing any information about your transaction. So we talked about we ended up touching on sort of three aspects. The first one being receiving transactions and how you can detect notes that are yours off the blockchain. Obviously in a full node case, that means scanning the entire blockchain. In a light client case, we looked at trade-offs around what amounts to essentially bandwidth versus privacy and versus usability. On the one hand, you can reduce it to roughly a stream of about 82 bytes per sapling output in the blockchain that your node needs to consume. On the other hand, at the other end, you give the server your viewing key. And that's okay if you run the server, or if you trust the server to see all the information about your transactions. But if you don't, then you want to at least try and find some happy medium. There are a couple of questions. One question that came up was whether we even needed to care about bandwidth, given that we have data plans that are pretty widely usable nowadays. But of course, the other point there is that may be the case here, but there are places in the world where that isn't necessarily the case. And if we do want to facilitate the at least the goal of usable privacy for everyone, then there will be areas where bandwidth remains a concern, and so being able to design within those constraints is important. So we looked at the synchronization side. We also then looked at spends and how when you're creating notes to spend, there's also additional data that you need to synchronize to do with specifically the anchor, the root of the commitment tree that contains the notes that you're trying to spend, and a synchronization of the data there, which isn't too bad, but we looked at the privacy aspects of that. Because again, the anchor you choose is a public value, and so it fixes the privacy set that your notes are in. Your choice of that is a distinguishing feature in your transactions. and so there's a usability to privacy trade-off there as well, because if you go, for example, to bucket the anchor so that you only choose an anchor that's a multiple of 1,000, say, at a height of multiple of 1,000, that means you can only, if you receive a coin, you can only spend it at least 2 days after you received it, which is a potential, that's quite a usability trade-off there. We had a bit of a discussion around ways in which developer libraries, so tying a bit into the previous workshop, how developer libraries could help this and create sort of like shelling points of standardization around ways in which to approach these privacy problems. In particular, at the moment, we essentially only have one client, the Zcash D. It's light in some sense, I guess, but not really. And obviously, if we want to create a light client, that immediately creates a second point which enables variations to happen, which can then lead to privacy set losses. So ensuring that as these things are developed, that there's a way to keep consensus about how these things go. And then also, there was a bit of discussion about whether it's possible to enforce some of these public values to retain certain values at a network level. So for example, that 100,000, say you're only allowed to pick anchors every 1,000 blocks, you could enforce that as a network consensus rule if we wanted to enforce more privacy. Or we could, say, make it 100 blocks, so you have to wait an hour. And maybe there's a privacy trade-off that there's a usability trade-off that the community might consider acceptable, that means that we can then remove a particular parameter from all the developers who end up creating these transactions, which removes another potential place that they could shoot themselves in the foot. And then we've also delved off a little bit into like blockchain compression techniques like recursive ZKPs and some fun stuff there, which again also has useful elements for like initial synchronization of a light client, quickly getting up to date with the state. And so there's some interesting ideas around that. And then one of the last points that was brought up, which was quite interesting, was about what amounts to really second layer 2 usages. So for example, the example that came up was, say that you've got a mobile and you want to pay for a coffee at a shop. If you could circumvent the server side entirely by using essentially a peer-to-peer operation, which could be as simple as the merchant shows a QR code that you scan with your phone to get the address. Your phone does we sort of want to ensure that there's consensus about how we approach these privacy things while designing these light wallets for the community to use.
Cool. I led the workshop on selective disclosure. So for those of you who don't know what that means, when you send a shielded transaction, you currently have the ability to create what we call a payment disclosure, which that allows you to share the details of that transaction with a third party, specifically the amount that's been transacted, the address it's being sent to, and the contents of the encrypted memo field, in a way that the third party can verify that information on the blockchain. And this is an experimental feature, so it hasn't been. You have to specifically enable it in the Zcash D software when you launch it. And the reason it's experimental is because there are many privacy implications about giving users the ability to do this sort of thing, where they might inadvertently compromise their own privacy. So that's payment disclosure. Selective disclosure is a concept where you can selectively choose which of those 3 fields you want to disclose to the third party. So you might want to disclose the amount that was being transacted and the destination address, but not the contents of the encrypted memo field, for example. So the workshop was on that topic, and we discussed some use cases for this sort of thing, ranging from the ability to share information with auditors through to whether it could be used to prove to a kidnapper that you don't in fact have all the money that they think you do. And there's some very interesting discussions about whether it was possible to add some features to the disclosure. First of all, whether it's possible to craft a disclosure which, if it was subsequently leaked, would identify the leaker. So Mark down here had that idea. And then we moved on to discussing whether it's possible to craft a disclosure that is only of use to a specific third party. Barry Whitehat, I don't really know your surname, Barry, suggested that there may be a solution to that where the recipient of the disclosure comes up with a random number and discloses the hash of that to the prover, and then if they disclose the proof, they must also disclose the random number, which renders that proof useless to another recipient. So looking at some qualities of the disclosures that may be of use. I think one of the key outputs of that is that we need to put Mark, Barry, and Daniel Baranock from Kedit into a room with Strad, Sean, and Dara, and I don't know, Simon and Nathan possibly as well, to explore some of these ideas, because I think they're really, really interesting and useful. But yeah, it's one of the points I made during the workshop is that although we were discussing some of the use cases, I think that in many cases, you know, when you create a technology and you create a system that has certain functionality, you can't always imagine some of the interesting use cases that it will be put to. Like, for example, I'd never heard of Zboard before just now, and it's really, really cool that some people can send a message and have it automatically posted, an anonymous message, and have it posted to a site using Zcash. So yeah, I think sometimes it's interesting to explore the technology, even though you haven't figured out what the use cases for it will be. But in terms of selective disclosure, I think there are some very clear use cases, and it's just a matter of figuring out how to implement it in a way that doesn't lead users to inadvertently shoot themselves in the foot, as we alluded to before. And I know that's something that Dara is very, very concerned about.
Great. So I and my colleague Eric led the workshop on privacy metrics. And our goal there was, well, really, Mary Mahler did our job for us. So she did a great presentation on what we based some of our work off of. So they released the paper, and you know, at the Zcash company, we wanted to maintain some of the privacy metrics that they published, but in a semi-real-time fashion. So we started working on this project, and we wanted to bring some of the community together to talk about what they might want to see out of it, and then maybe discuss some of the use cases. So in the actual session that we had, we talked about different ideas of metrics that weren't covered in the paper that maybe would be interesting to have, like IP address linkability, which is fairly common at this point. But there were also some other interesting ideas, like if we have nodes running all over the world, we could actually geographically link transactions based on their entry time into the mempool and things like that. So there were some interesting ideas that came out of it, and then the conversation kind of shifted into UX use cases of some of these metrics, which it kind of resonated with some of the things Linda was talking about. And I think the best idea that came out of it, and we split up into two groups, and both groups had a very similar idea, was to use some of these privacy metrics to kind of create a privacy score within a wallet, right? To where we can actually see real time, if this amount is linkable, if you are doing something that shouldn't be done, if it's going to expose your privacy, and showing that to users in real time. I thought that was a really great idea. A couple other smaller ideas, like doing some event-driven analysis, so just being very transparent from the company's side, to where if there's an event that triggered something statistically significant in some of the actual metrics we were looking at, then maybe digging down to figure out what that event was and disclosing it, and really trying to promote the trust and understanding from the entire community about what's happening in the network. So brevity being the soul of wit, I think that's about it.
Questions? It's hard to see from here because you have lights in your eyes, so I can't see any hands up. You got a hand up, Shout and wave. Or does everybody just want to get to the bar? Maybe microphone.
Sorry. For the developer libraries, amongst the audience and the participants there, what kind of languages did you get a sense of what languages people were most interested or that they're using on a day-to-day basis?
The ones that came up for that were JavaScript, Rust and Go, and Python were the ones that were mentioned. Go in particular was interesting because they're like, well, the Go community wants to really implement the entire stack themselves, which is fine. I mean, it would be really good to have entire parallel implementations of the entire sapling cryptography stack, both for just like stability and doing fun interoperability testing suites, which one of the things I really like about what Lightning Network did before they launched was had like a full interoperability testing suite between the 3 implementations. So that kind of thing would be very useful, also for like flushing out bugs. And then just, it gives obviously more variety in terms of what people want to interact with. On the front end side, it was, those 4 were the ones that were primarily brought up.
And was there any sort of like conclusion that the development team should create libraries for folk to use in these different languages?
There was some discussion of that, and obviously, like one direction that the community could go is essentially like implementing something and give a package in npm and pip for Python and Debian repo, Docker, like just go the whole gamut. And of course, that's where your combinatorial explosion comes in, and that you're essentially having to do like a package for absolutely everything under the sun, and that does satisfy the whole everyone who has the exact specific thing they want to use would be satisfied, but there's a lot of work that would have to go in behind that. Some of that may be able to be automated, but and there was a point made that potentially, for example, automatic generation of certain bindings for if you have like the Rust library and then generating bindings for a bunch of different languages, that may be a way to reduce that load. But then what you may also want to do is whether those automated bindings are sufficient or whether you do need more different paradigm languages are obviously going to have different native paradigms for what Go developers like to use, what kind of API they like to use versus what API JavaScript developer likes to use. So there may end up being some benefits to more contextual architectures. And we sort of touched on that a little bit also from the perspective of proving system libraries, because we're also developers of those too. And we have a similar situation where we've got a couple of different back-end, low-level proving libraries, and then a bunch of people developing domain-specific languages for their specific use cases. And so there's a sort of crossover in between where what you're really looking for is a common API in between, so that you can sort of plug in and out as you need, while still everyone can sort of speak the same language.
So if you have multiple parallel implementations of a full node, do you think it's feasible to do that and sufficiently mitigate the chance of chain splits because of unintentional differences between the implementations?
That's a fun question. Thank you.
I only do fun questions.
I know. So yeah, this is one of the motivations behind why Bitcoin Core only promotes Bitcoin Core, because a single implementation can be bug for bug compatible with itself by definition. And what it comes down to then is okay, what risk are you willing to take as far as having multiple implementation goes? Because yes, if there is a bug, if there's something that one allows and the other doesn't, then yes, you're going to essentially get, depending on the type of bug, you'll either get a soft forking change where one starts restricting, and then one starts rejecting certain things, then the other is happy either way. Or in the worst case, you have conflicting bugs where the two end up diverging. And I think we've seen cases of this in Ethereum. So that's actually quite a good case study for this, where they have two ongoing clients of like, I think 40 and 60% usage in the network each. So it'd be good to do some studies like bug incidences and how easy it's been for them to recover.
Yeah, I'm not familiar with the specifics of any bugs they've had, but it seems like a really hard problem to be. Especially if you're starting with a Bitcoin code base that was never very clearly documented or specified to start with. The difference in specification precision between the parts of the Zcash protocol that we've added and the parts that we inherited from Bitcoin is really stark. So I would be more confident of being able to do that for the shielded part than the...
But over time, I think that the well-specified portion is likely to grow.
I hope so.
And then, hopefully, the risk that comes with code as specification will reduce. I mean, I think it would be great to have multiple independent implementations. But it does require a well-specified protocol.
Yeah. We've seen in the development of Sapling, about partway through, we decided to do an independent Python implementation. And that was so helpful, even though it's not going to be run on the production network.
It's way too
it's
slow.
we're only using it for test vectors. It's still extremely valuable to have that implementation.
And also note that there is a way to sort of migrate this because we are doing network upgrades. Like you could envisage like if in the absolute like burn the forest down and plant it again mode of software development, you could construct a Zcash binary that contains the old one and then a new one. And it uses the old one up until the hard fork activation and then shuts down and restarts using the new binary. So everyone would then essentially agree on you're essentially switching to a new code base. So if you could, in theory, develop a new code base that had severely lower risks of these kinds of things, developed in a multi-implementation way, and then just like wholesale switch everyone to it. In the same way that if you're switching proof-of-work algorithm, everyone has to like shut down their old proof-of-work prover and start up the new one. There are ways that you could get around that.
If we have no other questions, I guess we can go downstairs and drink.
That sounds like an excellent idea.
Seconded, thirded, fourth.
So the welcome reception technically starts at 5:30, so feel free to take your time to get down there. It is in Agora. It is the room. If you go down the escalators to the left, you'll see it. It's kind of the extension of their lobby. And we look forward to having you. And thank you guys so much. Thank you.